On February 19th, 2026, a refinery in California exploded. 2 weeks later, another one in Texas caught fire. 18 days after that, one of the largest refineries in the United States was hit by a blast so loud it shook homes for miles, sent black smoke into the sky visible from neighboring counties, and pushed crude oil prices above $90 a barrel within hours. Then it kept going. A refinery in Australia, a refinery in India, a power plant in Romania, an oil well site in East Texas, a tanker depot on a river in Myanmar. 8 major industrial incidents, 4 continents, 60 days. Each one has its own official explanation. A valve leak here, an electrical fault there, equipment failure, hydrocarbon ignition. Each one is being investigated separately by separate authorities in separate countries, but industry veterans are starting to ask a question nobody in an official capacity wants to answer. What is actually happening to the world's refineries? Let's lay out exactly what happened. February 19th, Chevron's El Segundo refinery in California, one of the largest in the state, exploded. Emergency response was triggered. The fire was contained quickly. Operations resumed within days. March 5th, Marathon's Texas City refinery caught fire. It was brought under control. There were no major injuries. The Gulf Coast refining corridor was now on edge. March 23rd, this was the big one. Valero's Port Arthur refinery in Texas, processing up to 435,000 barrels of crude per day, one of the largest in the United States, suffered a catastrophic explosion at its diesel hydrotreater unit. The blast shook homes miles away. Windows rattled across mid-county. Residents on the west side of Port Arthur were ordered to shelter in place. Black smoke columns rose, visible from neighboring counties. Witnesses reported the smell of rotten eggs in the air, an indication of sulfur release. Within hours, West Texas Intermediate crude jumped back above $90 a barrel. Mid-April, Viva Energy's Geelong refinery in Australia catches fire in the alkylation unit of its gasoline complex. Diesel and jet fuel production drops to 80% of capacity. Petrol production drops to 60%. Union officials note that the facility has a history of leaks and that some maintenance had been deferred. April 20th. This is when things get strange. In a single 24-hour window, 3 major incidents hit 3 different countries. In Rajasthan, India, the HPCL Pachpadra refinery catches fire at its crude distillation unit. The fire is traced to a hydrocarbon leak through a valve in the heat exchanger circuit. The damage forces the postponement of Prime Minister Modi's scheduled inauguration the following day. This is India's first greenfield integrated refinery-cum-petrochemical complex, a $9.5 billion project the country was depending on to offset import disruptions from the Strait of Hormuz. That same evening in Bucharest, Romania, a 10,000 kilowatt electrical transformer at the CET Vest thermal power plant explodes. The transformer contained 30 tons of insulating oil. The fire spreads to 2 more transformers. 3,000 apartment buildings across western Bucharest lose hot water. Romania's energy minister later announces that repairs could take up to a year. Authorities are investigating possible external interference. And in East Texas, an explosion at an upstream oil well site in Nacogdoches County sends flames visible for miles and triggers precautionary evacuations. 3 incidents, 3 countries, 1 night. If you are already wondering what is connecting these events, subscribe right now, because what comes next is the part most coverage is not talking about. And if you have a theory about what is actually going on here, drop it in the comments. I read them all and I want to know what you are seeing that the official explanations are missing. The numbers behind the pattern. Industry analysts have a baseline for how often these incidents normally occur. Equipment failures, valve leaks, and process upsets have been part of the oil industry since its inception. The industry has always had fires. It has always had explosions. A handful of incidents per year, scattered across the global system, is normal. 8 major incidents in 60 days across 4 continents is not normal. That is roughly one significant event every 7 to 8 days. This is well outside the ordinary frequency for the industry. Industry veterans are flagging it openly. So the question becomes, what changed? The pressure cooker. Here's the part most coverage is missing. The global refining system has been running unusually hot since late 2025. Refinery utilization rates, the percentage of total refining capacity actually being used, have been at multi-year highs. Some facilities have been operating near or at maximum throughput for months on end. Why? 2 reasons, both connected to events outside the refining industry itself. The first is the Strait of Hormuz. Following the joint United States and Israeli strikes on Iran in February 2026, shipping through the strait, the route that carries roughly 20% of the world's petroleum trade, has been disrupted. The International Energy Agency reported that global crude throughputs were cut by approximately 6 million barrels per day in April alone. That's not a minor disruption. That's a shock to the system. The second is Russia. Ukrainian forces have been conducting a sustained campaign targeting Russian energy infrastructure throughout 2026. The NORSI refinery suspended operations after an April 5th strike. Tuapse was hit twice within a single week. Russian refinery output is being deliberately removed from the global supply. When 2 of the world's largest sources of refined product capacity are simultaneously constrained, one by war and one by blockade, the rest of the world's refineries have to make up the difference. That means running harder, pushing throughput higher, deferring maintenance windows that would normally take a unit offline for inspection and repair, which is exactly what union officials at Geelong said had been happening at their facility before the fire. And it's exactly what industry veterans are flagging across the cluster. Here's what happens when a refinery runs at maximum throughput for extended periods. The equipment is not designed to operate at peak capacity indefinitely. Valves, flanges, heat exchangers, hydrotreater units, and alkylation units are built with maintenance cycles in mind. They are inspected, taken offline, repaired, and brought back up. That is the normal rhythm. When you defer that maintenance because you cannot afford the downtime, the components keep working. They just work closer and closer to their failure thresholds. A pressure gauge tapping point on an inlet line, a hydrocarbon leak through a valve, an electrical fault in an aging transformer, a diesel hydrotreater under sustained load. These are not dramatic causes. They are the boring structural failures that show up when an entire industry is being asked to do more than its equipment was designed for longer than its maintenance schedules allowed. Each individual explanation is true. The refinery in California really did have an equipment failure. The fire in Rajasthan really was caused by a leaking valve. The transformer in Bucharest really did have a fault. But the reason all of them are happening at the same time across 4 continents is the same reason. The system is running too hot. The question nobody is answering. Here is what makes this story unusual. If this were one incident, it would be a story about industrial safety. If it were 3 incidents in one country, it would be a story about regulatory failure. If it were 2 incidents at the same company, it would be a story about corporate negligence. But 8 incidents across 4 continents at facilities operated by completely different companies under completely different regulatory regimes, and each one occurring during a period when the global refining system is operating under unprecedented strain. That is a structural story. Structural stories are harder to investigate because there is no single agency, no single company, and no single country responsible for the global pattern. The IEA tracks the macro data. National regulators investigate the local incidents, but nobody is officially responsible for connecting the dots between record high utilization rates, deferred maintenance, geopolitical supply shocks, and the cluster of failures showing up across the global system. So the question stays open. The timeline is not slowing down. The European Commission has launched an $86 billion clean energy strategy in response to the broader supply pressure. But the International Energy Agency has cautioned that renewables cannot substitute for oil-derived transport fuels in the near term. The world's refining capacity remains the critical infrastructure for global supply stability, which means the same pressure that produced these 8 incidents in 60 days is still in place. Refineries are still running near capacity. Maintenance windows are still being deferred. The Strait of Hormuz is still constrained. Russian capacity is still being removed. If the pattern holds, there will be more. So I want to hear from you. Was this just a string of unrelated industrial accidents that happened to cluster by coincidence? Is it the predictable consequence of a global refining system being pushed past its design limits? Or is something else happening that the official investigations are not capturing yet? Drop your theory in the comments. The smartest commentary on this channel comes from the audience, and I want to see what you're connecting. If this video gave you something the headlines did not, share it with someone who needs to understand what is actually happening to the world's energy system. And if you want more breakdowns like this, the patterns, the structural causes, the things hiding inside the news cycle, hit subscribe. 8 refineries, 4 continents, 60 days. The official explanations all check out individually. The pattern is the story.